TCR project, which is the Transformational Challenge Reactor, which is looking at really changing how nuclear energy is manufactured. We had a really unique opportunity as part of this program to work with Framatome, which is a producer of nuclear technology, and the Tennessee Valley Authority, and make a part that could be inserted into a nuclear reactor. We successfully did that, and we actually put a channel fastener, which is a safety critical component, into the Browns Ferry reactor in Alabama on April 22nd. That reactor went live. We're using additive manufacturing or 3D printing, specifically on the powder bed technology. So we take metal powder, in this case it was 316 material, and we put it into a system where we create a three-dimensional geometry from that powder through laser processing. We are trying to help effectively create, certify the next generation of nuclear components. Our characterization process includes computed tomography, and we can do CT scans to create a 3D representation of the material. And so we can look at the entire component, or we can zoom in on specific areas of interest that might be critical. And we would polish that material to look at the metallurgy. So we use a combination of optical and scanning electron microscopy, even transmission electron microscopy, where we're looking at things down at the atomistic scale. And then we spatially are tracking all of that data to make sure that we understand how that material will compare to a conventionally processed material. That entire characterization process is good from the metallurgy perspective, the defect perspective, and then we also have to include the geometric accuracy and surface roughness perspective. And then we can couple that to other measurements as well, like light microscopy and point method, and all three of those will determine how your part actually performs in service. One of the most significant outcomes is something that we are doing on the digitization of the manufacturing process. We have created the mechanism to take images of every single layer that we print during the entire process, transferred and digitally analyzed using artificial intelligence-based software, and it gives us an understanding of every single defect that could possibly be in that component in three-dimensional space. We can couple that information to the actual end inspection and characterization of component. One of the wonderful things about Oak Ridge is we have a bunch of advanced manufacturing technologies, but we've also been doing this for an extremely long time. After we ran through and collected all of the data here at the MDF, we took those over to main campus where we have conventional inspection technologies and individuals with experience in the nuclear quality inspection. So they went through all of their procedures that they would conventionally go through in order to certify that this component was good and of quality. These brackets will remain in the reactor for the next 6 years. And after 6 years, they will be pulled out from the reactor, brought back to Oak Ridge National Laboratory, where we can do a full inspection and evaluation on those components to understand how they actually performed. Framatome and TVA have reached out. We're going to continue looking at additional components that we could put in and do a similar experiment on and study. A lot of these kind of small modular reactors that are coming about, we need advanced manufacturing technologies for them. We need advanced manufacturing technologies for old reactors. And if we can do that, I think we'll significantly change the energy landscape here in the US.